Take a look at last night's homework, page 35. Page 35. Any questions you want me to go over on page? Yeah. Number 5, you got it. All right, problem number 5, page 35. It says a small airplane sold for 1.3 million and its value is decreasing 150,000 per year. What will it be worth in 7 years? Okay, so this is how much the airplane cost, right? But every year it's just going to take a $150,000 decrease. So I can subtract 150,000 from this 7 times, or I could realize if I multiply this times 7 and do the subtraction, 1.3 million minus 150,000 times 7. So this is a linear decrease in value. It's not exponential. Okay? So let's see. Let's go here. So I'm going to go 1,300,000. Yep. Minus 150,000 times 7. Okay? So it's just doing the subtraction of that. So that comes out to the airplane in 7 years will be worth $250,000. Okay. Does that make sense? So if you don't recognize this way, you can say, okay, I'm going to take 1.3 million or 1,300,000 minus 150,000 minus 150,000 minus 150,000 minus 150,000 minus 150,000 minus 150,000 minus 150,000. You still get 250,000. Okay?
What about number
7,
7?
you got it. Yep. Number 7 is going to be done the same way. It's a linear thing where you're increasing now. So number 7, they told us that we had this many people. The population of Newton is 65,000. It grows 2,500 per year. Okay, so it's going to grow 2,500 every year. How many years is it they looking for? After 15 years. Okay, or again, you could go 65,000 plus 2,500 15 times. Okay, it's your choice which way you want to go. Let's see if we can do this. So that's going to give me 65,000 plus 2,500 times 15. And order of operations would say do the multiplication first, right? So hit enter. So it looks like 102,500 or 102,500 people. B, you had one you want to see? 2? Yeah. All right, problem number 2. It's linear, isn't it? They have r at x. That's equal to 2x minus 3. Okay, so my y-intercept is going to be that. And then I'm going to go up 2, right 1. Done. Yeah, all right, go ahead. 3. Yep. Number 3, we have p at t equals 10.5 raised to the t. Okay, that's exponential. Okay, technically there's a plus 0 here, so here's my horizontal asymptote at y equals 0. Remember, y equals 0 makes a horizontal line. Where crosses the y-intercept, I'm going to plug 0 in. So 0.5 to the 0 is 1. 1 times 10 is 10. And then if I plug 1 in, 0.5 to the first is 0.5. So what's 0.5 of 10? That's 5. So 1 comma 5. That's what this looks like. Is that growth or decay? Decay, because as I go to the right, I come to my asymptote. Number 1. Okay, so technically that's plus 0. Here's my asymptote. Again, y equals 0. Let's figure out where it crosses the y-axis. So plug 0 in. 2 to the 0 is 1. Plug 1 in. 2 to the first is 2. Looks like that. And that is growth, because as I go to the right, it goes away from the x-axis. Yeah.
We do number four.
4. Population of Stockton is 132,000, growing at 3% per year. Will the population be in 10 years? Okay, so this is use this equation. It's plus because it's growth, right? Plus because it's growth. Okay, so you have 132,000. 1 plus, if you have 3%, make 3% a true decimal, that's 0.03 raised to the 10th. So, those extras?
Yeah.
Thanks. All right, so if I plug this in to the calculator, 132,000. 1 plus 0.03 raised to the 10th power. So it looks like there's 177,396.9. So it probably, if you round it up to 177,397, you'd be fine. Should I do number 6 just to say we did them all?
Yeah.
All right. I already did 1. All right. Oops. Number 6. You have a $17,500 car. It decreases by 16%. What will be worth in 4 years? So I'm going to go y equals a 1 minus r. Why is it minus? It's decreasing. 17,500 minus, what's 16% as a decimal? 0.16, good. Raised to the t value, which is that. So plug into your calculator. So your $17,500 car in 4 years is worth $8,712.75 rounded to the nearest penny. All right, I did them all. Not in order, but did them all. So please make sure your name's on those and pass those forward. You can jump back in, take a look at this if I went too fast, okay? But for sake of time, I just want to make sure I get through it. Problem number 1, we have f of x is equal to 4 to the 1/2 power, or 4, like that. I want to graph it. Okay, so first thing I'm going to do is I realize this is plus 0, so I have a horizontal asymptote right here, right? Agree? Because I didn't answer that question yet. I didn't get the y-intercept. Watch, ready? So let's get the y-intercept. So I'm going to plug 0 in. 1/2 raised to the 0 power is 1, yes? 1 times 4 is 4. There's your y-intercept right there. Okay? Plug 1 in. 1/2 to the first is half. Half times 4 is 2. So I get 1 comma 2. So this is what this graph looks like. Okay, so let's answer things. So the y-intercept answer is, you could have had 0, 4. Horizontal asymptote, we'll refer to that as ha, is y equals 0. It's an exponential function. It is decay because it approaches my asymptote. What is the average rate of change from 1 to 2? So I need this point here, and then I need to figure out another point here. So I'm going to plug 2 in. Half squared is a fourth. A fourth times 4 is that. So that's a 2 comma 1. So then I'm going to find the slope between these 2 points. So I'm going to go 1 minus 2 is negative 1. 2 minus 1 is 1. So what's the rate of change between 1 and 2? This is the answer to E. If I want to find the average rate from 0 to 1, I'm going to use these two. So I'm going to find the slope. So 2 minus 4 is negative 2. 1 minus 0 is 1. So that's the average rate of change for F. Okay? So the rate of change changes. The rate of change means you're finding the slope between 2 points. So, yeah.
Can't you also figure out the rate of change by looking at the graph? Counting down,
I guess you could, yeah. Did you get the same answers as me?
down 2 over 1.
Sweet, I just used the slope equation, but yeah, you could do it. Yeah.
I put +1 and +2,
Plus
but
1.
you didn't like mark it off.
Oh, I wouldn't say a word then.
Well, I was wondering because like you could go
I probably grade.
like on the.
I probably
graph-
graded your. I was grading some too quickly, so I sometimes make an error.
Well, it's fine.
Okay.
It's
All right.
fine.
All right. Problem number 2. The two of you, I'll have this test graded for you. If you want to come see me sometime today before 5th period, I'll have it, and then this is all recorded so you can have it as a reference, okay? Problem number 2, I have f of x is equal to half x minus 5. This is a linear equation, agree? So my y-intercept is negative 4, or negative 5, excuse me. And I have a slope of up 1, right 2. Okay, what is the y-intercept? That's at 0, negative 5. We skip b, right? We don't have a horizontal asymptote, so b we didn't do. C, it's linear. D, what is the rate of change, and what is the rate of change? Well, the rate of change, the slope for any linear equation, so answer to D and E is the exact same answer. It's whatever the slope is. So this is the slope. There's nothing further for you. Okay? Number 3. I have g at x is equal to negative 1 times 4 raised to the x plus 6. Okay, so I have that right there I have to contend with. Okay, let's plot some points. So if I plug 0 in, 4 to the 0 is 1, so this becomes 1. 1 times negative 1 is negative 1. Negative 1 added to 6 is 5. So I get 0, 5, which is right here. And then I plug 1 in. 4 to the first is 4. 4 times negative 1 is negative 4. Negative 4 plus 6 is 2. Okay, so this looks like this. Okay. The y-intercept, this is my y-intercept. We don't have to worry about the slope. We don't worry about b. This is exponential. It's exponential growth. The reason it's growth is as I go to the right, the graph goes away from the asymptote. Yeah. 0, 5. 0, 5. That's your y-intercept right there. That's exponential growth. And then what is the average rate of change from 1 to 2? Well, you already have this point that we're going to use right here. And then I have to find the second point. So if I plug 2 in, I get 4 squared, that's 16. 16 times negative 1 is negative 16. Negative 16 plus 6 is negative 10. So now I'm going to find the slope between these two. So negative 10 minus 2, negative 12. 2 minus 1, or so negative 10, yep, and 2 minus 1. So this is my average rate of change. So that's the answer to D. Okay, I think I've answered everything on that one. Someone's got music on. 4, I have g at x is equal to negative 1/3 x plus 6. This is a linear equation. It's not raised to an exponent. My y-intercept 6. And then I'm going to go down 1, right 3. Someone still has music on. So the y-intercept is at 0, 6. The slope is negative 1/3. It's linear. And what is the average rate of change? The average rate of change always has to be the slope. So that's the answer to D. Okay? Problem number 5, if you look down below, it goes 40, 20, 10, 5 in the y direction, so that's exponential. Number 6, it's a linear function, 1/2 x minus 4. And then problem number 7, the y direction, I go 15 to 10, 10 to 5, 5 to 0, so it decreases by the same amount. So number 7 is linear.
Oh, so if it goes up,
See?
down, up, down, that's the
Exponential, like, so if you look on number 5, it goes from 40 to 20.
Yeah, if the y goes up, like, because when it goes up.
See how y is getting cut in half each
Also,
time?
if it gets, like,
So,
a
so
further jump down.
if you don't add or subtract the exact same number from each y value, it's got to be exponential.
So, like, 5, 5, 5, 5, it's just like 10, 15.
All right, number 5. Okay, pay attention to these. 7x times x to the 5th. Like bases, that's x to the 1st. So like bases, add the exponents. There's my answer. Number 6. X to the 3rd times x to the negative 3. Like bases, add the exponents. So you get x to the 0. Something to the 0, 1. Okay? Can I move off that screen? Number 7. Hey, Bo. Ching. Giddy up. All right, this next one. I need to distribute that here and here. So I'm going to get 16 because 4 squared. And then x to the 6th. Power to power, multiply the exponents. Number 8. I don't want a negative exponent. So this is going to move straight down. Okay, number 9. Let's get your test. Oh, you were already here, aren't you? Yeah. Oh, sorry about that. Get it? Is it quiet in there? A to the negative 2, B to the 3, C to the 4. Did you get it?
Yeah, just I forgot that.
Oh, perfect, thanks. All right, let's see. This needs to move up. So how many A's are on top then? 6. This needs to move down. So how many B's are downstairs? 8. Tug of war with the C's. Who wins? Top by how many? Done. Number 10. I'll just squeeze 10 right here. All right. This whole thing's raised to the 0 power. So anytime you have a whole quantity raised to 0 power, the answer is 1. There's a lot of you still putting 0. I don't know how I can say that any more clearly. You're not multiplying by 0. You're raising. It's an exponent of 0. Can I move on? All right. Number 11. So you have 5 times 10 to the 7th squared. So that comes here. That gives me 25. That comes here times 10 to the 14. Is that okay so far? So if my decimal is right here on this problem. So that means I'm going to move the decimal 14 spots that way to get it out of scientific notation. But I want the decimal right here. So that means it's going to move one more spot to the left. So it's times 10 to the 15. Think about it. This to the 14th means I'm going to go this way 14. If I came all the way back and came back in one more, I had moved 15 spots. Yeah.
Why is it, for that exponent that is raised to 7, why isn't it 49 instead of 14?
Power to power, you multiply the exponent.
You multiply the exponents then.
7 times 2. Right? All right, number 12. Times 10 to the 3rd. 8 times 10 to the negative 8. All right, so 1 times 8, or 2 times 8 is 16. keep it like this. I'm going to add the exponent, so I get 10 to the negative fifth. So right now my decimal's sitting right here, which means if I wanted to rewrite this not having that to the negative fifth, that means I would move this way 4 spots. So I want the decimal right here. So I have 1.6 times 10 to the negative fourth. So I already moved it. $13, guys and girls, I promise you this. If you go square root of 12 on your calculator, you miss the entire problem. Okay? We're looking for you to break this up into 4 times 3. That's the biggest perfect square, so I get 2 square root 3. Done. If you give me the decimal approximate, you missed it. Yeah, but my calculator. Yeah, that's what we're looking for. Number 14. I have 4 root 75. I'm going to break this into 25 times 3. So that's going to be 4 times 5 root 3, because it's square root 25, which is 20 root 3. All right? $15, 4 root 3 times 2 root 15. I'm multiplying these, so I'll go 8 times, or 4 times 2 is 8. Inside I get root 45. 45 is going to break down to 9 times 5. Square root of 9 is 3. So that's going to give me 24 root 5. Okay, so when you're multiplying, multiply inside, inside, outside, outside. Now number 16's difference is this. I'm adding them. You have to have like bases when you add them. So if you have like bases, you're just counting. So I have 5 root 6s we're dealing with. We're done. You don't add inside, inside, or subtract inside, inside. Just multiply, okay? Doing good on time. Can I go to 17? Number 17, I got 2 root 24 plus 3 root 54. So right now they are not like bases. I cannot add them together as they are because root 24 is different than root 54. So let's break 24 down to 4 times 6. And let's break 54 down to, let's see what that break down to, 9 times 6. Is that right? So the square root of 4 is 2. So I have 2 times 2 root 6. So this one becomes 4 root 6. Plus, square root of 9 is 3. So that becomes 3 times 3 root 6, which is 9 root 6. Now just count them up. How many root 6s do you have? 13 of them. And the last question. Number 18. So I get 3 root 7 quantity squared. This comes here, and it comes here. So I get 9 root 49, because 7 times 7, right? Square root of 49 is 7, so I get 9 times 7. So my answer is 63. That, ladies and gentlemen, is quiz number 2. That's quiz number 2, okay? So, let me hand this out to you. So a few things are taking place. Tomorrow, I won't be here. I will not be here. Okay? I'm giving you the take-home test so you can get a start on it. Then you have tomorrow to work on it together. I left it in the sub-plans that if you wanted to go onto my videos to watch, please do. But I also asked the sub, please make sure that you're watching my video, not, you know, oh, take a look at that, cute puppies. Okay? Sound good? And then this will be due on Friday. This will be due on Friday. Remember, I grade it for if you have the right answer or the wrong answer. I don't grade it for any partial points. If you happen to forget to bring this tomorrow, I have enough copies, hopefully, for at least some of you. I made 120 copies. I have 70 students that I handed. I forgot you. Sorry. So hopefully 20 of you between my three classes remember to bring this back. So the test will be on Friday. So you'll hand in this take-home test Friday. Test is on Friday. Okay?
Yes, sir.